Hello there, guys. Gallo here. Well, not today, but a few days ago, I was talking to this guy called This is Vinny, and he was doing 2D Pathfinding, follow player, 5-star game develop. Summing up, he was making a pathfinding system for a platforming game. And by total coincidence, I was working one myself. Vinny was using godot pathfinding system that is really finicky for this use case. Like has to do everything by hand. For example, this here is how we have to do it. Like create, like have to do everything by hand. And you can imagine how painful it is to do that. It's really annoying, if I have to be honest here. Not going to do the whole thing, but the process kind of goes like this. And as you can see, can be a lot of work if you have like a really big level. So in my use case, I came here in his video and I commented here, "Hey man, I have been working a sub-pathfinding algorithm for side-scrolling platformer games for the Godot engine that procedurally generated this nav mesh without the need to create it by hand. They have any interest in me lending a hand?" Now I posted this on this video a couple of days ago, and he replied, "Thanks mate, at the moment I'm happy with my current approach, but those sounds interesting. Let me know if you release any content about it." So now I'm releasing the content. So what I did here, let me show it first. Showing practice. Let me check the settings. Okay. Let's just show how it's working right now. As you can see, the AI is following me. Those are enemy AIs. They try to shoot at me and attack me in general. They're not friendly. Differently from Vinny, those guys are really evil. They just want to kill me. And it's two kind of AIs there. It's a shooter AI and a melee AI, and they're slightly different. I'm going to explain how each one works later on. But yeah, the AI sometimes kind of miss the jump. Sometimes manage to do it. As you can see, it's pretty smart. And you must be wondering if I made a nav mesh by hand, and the answer is no. All of what you're seeing is automated. Oh, they caught me. So let me show you how the system works exactly. For this I have to delete a file that is generated every time we're going to see. Baked. Okay, let me boot this and you're going to see what happens. Let me explain what's happening right here. All the blue dots, the blue squares, they are generated points above the tile map. It first generates all these points based on an algorithm that detects if the tile is full, but the tile above it is empty, it creates a point. And as you can see, you have all these points above the tile. Then, to check if those points, if the object can go between these 2 points, it's trace array. The blue lines are rays that they didn't collide with anything, and then they were connected by the computer to generate a path, because it's pathfinding. You know, the computer calculates a path using these rays. The red ones, they are the rays that intersected with something else, generally the tile map, realize that the object can't go through there, so it's marked on red. As you can see here, this yellow line that's being represented on the screen is the pathfinding of each of the actors. It's following those blue lines I showed off before. Let me show this with the blue lines to make it even more clearer, so you can see the path it's taking. As you can see here it is. You can see it's perfectly following those blue lines. It's using the A-star algorithm to calculate the shortest path between two of these lines. Giving credit where credit is due, I took a lot of inspiration from arithmetic. I took a lot of inspiration from his pathfinding algorithm, but mine's a bit different. I still recommend watching his video on pathfinding, it's pretty good. Event reward algorithms are quite different. I still think watching his video is going to give you a really nice time. As you can see, it's extremely precise. So I recommend subscribing on his channel if you're not subscribed already. Now I'm going to show here some of the logic. As you can see here, it's a couple hundred lines of code because it's really big. One of the biggest difference between his code and mine is that mine have a baking function that saves everything to this file here. It's around 260 kilobytes, so the file is not very large. This number here is the boot time, the time it takes to boot the game. Let me show you. Before it's 500 milliseconds. Now that we have this algorithm here, it fell down to like 57 because it's way faster. My algorithm is a bit different from his, not only because of the baking, but the enemy were completely different. The way his AI was made is completely different. He uses a couple of switch states, machine states, yeah, that's the name. So just let me create here a project to kind of show how this algorithm works under the hood. So what the algorithm does is that, let's say I have this terrain here. I'm not going to draw anything precise. It's this, let me see, size. That thing's going on weird right now. Speed, okay, that's why. Let's say this is the map for our game. So what the algorithm is going to do is that it's going to check every tile that exists on this game. Just going to check every single of those tiles, and then going to ask, hey, in this tile here, it's full, okay, is there something above it? If detects something above it, then it does nothing. But if it goes to this tile here and check if there's something above it, it checks. So it creates a point. And this algorithm do that multiple times, creating multiple points along it, alongside it. Now we create a bunch of points everywhere, and then it's going to check out the possible collisions between these points to see if they can be generated. And then I'm going to connect them. And for example, if some of these points they can't coexist because they are simply not shouldn't be connected, you know, like those here. Let me show in green. If points are like that, then it's not going to go. The computer is just going to say nope, and it's going to throw this pathfinding. And then if you have the enemy here in yellow and the player in purple here, it's going to draw a path to the player. Let me get orange. It's either going to be through here or maybe through here. It's going to get one of the two paths. It depends on a star. I don't really know exactly. I never worked with A star before, but it's really fast. So I use that instead of some other pathfinding algorithms that you have around. I think I'm going to leave the code for this here in the description. Because two pieces of code that decides everything. It's the pathfinding that creates out the path, and the pathfinder that it's way simpler. It's like 40 lines of code that that traces the path to the node, and then the parent script's going to get that path information and use it to navigate to the player. So if anybody's interested on this algorithm, hit me up. I'll probably leave a link on the description and our arithmetic channel in the sub. So yeah, thank you very much for watching this video. Goodbye.